Hey guys, equation of the week. We're doing the Zeno Sum. So, can you add an infinite number of things and get a finite number? That's Zeno's paradox. And in this example, we got 1/2 plus 1/4 plus 1/8. We're cutting our next term in half each time. So the next one, 1/16, after that is going to be 1/32, 1/64. It's going to keep on going, get smaller and smaller. Is this equal to or less than infinity? That's the question. So let's do a little diagram here. Let's start with 1/2. Let's say this square is 1. 1/2 would be about there. Oops, let's do it with fill. Okay. So that 1/2 is right there. Okay, sweet. Then we got 1/4. So that's going to be half of what we just filled in, which is about there. Okay? Let's do a slightly lighter color, actually. Let's match the number that we have. Okay, 1/4. After that, we got 1/8. And something that you'll notice is each area that we fill in is half of the remaining area. Okay? So there's 1/8. 1/16 is going to be, again, half of the remaining area. It's about there. As you can see, if we keep going in this direction, I'll just do a few more. This would be 1/32. About there. And then 1/64. And if we keep on adding half of the remaining area, we're never going to add more. We're never going to add more than the remaining area. So we can't be bigger than 1. At most, this is going to be 1. So let's just say equal to or less than 1. That's the biggest it could be, and it's going to be greater than 0 because there's no negative terms. So somewhere in between 0 and 1, so obviously it's a finite number. And actually, it turns out that it does equal 1, okay? As we could see from this little graphic here. Now let's do it kind of more mathematically, more with some of the maths. This equals 1. Let's write this in sum notation. So this sigma, this is the letter sigma in Greek, and it means sum. So it means we're adding things together. And what we're going to be adding is 1/2, but not just 1/2. This is 1/2 times 1/2. And then this one is 1/2 cubed. This one is 1/2 to the 4th. So each term is 1/2 to the number of that term. So if this is the first term, this is 1/2 to the first power, meaning it's just 1/2. The second term, it's 1/2 squared, okay, because 1/2 times 1/2 is 1/4. So we're going to start at the first term, and then we're going to sum up an infinite number of times, and that's going to give us 1, okay? Well, at least that's what we think based off of our intuition. So this is actually a geometric series. A geometric series is something of the form a times r to the n minus 1, okay? So in order to do this algebraically, we need to know the exponent is n minus 1. And the formula for this is 1 minus r in the denominator, and then a in the numerator. So a over 1 minus r. So r is clearly 1/2. We know that. Let's just write it in a slightly different form, though. It's going to be some constant, times 1/2 to the n minus 1. What do we have to multiply 1/2 to the n minus 1 to get 1/2 to the n? Well, we have to multiply another 1/2 because we dropped a factor of 1/2 here. So we got to add another factor of 1/2 here. And now it's in the right form that we want, so we could say this is going to be equal to a over 1 minus r. Okay, 1 minus r, in this case, is 1/2. 1/2 over 1/2 is 1. So there we go. There it is. This makes us happy because it goes with our intuition. And that's the Zeno sum. It's a geometric series that equals 1. Now, next week, we're going to do another sum, but it's going to be the Basal Sum. And it's going to be a little bit more interesting. It's going to require a little bit more thought and a little bit more math. And I'm actually going to write it down right here. So this one that we just did, the Zeno Sum, is from n equals 1 to infinity. And I'm going to write it slightly differently. Of 1 over 2 to the nth power. Okay, that's another way to write it because your exponent rules, right? A over b to the nth power is equal to a to the nth over b to the nth. Okay, and so then we get 1 to the nth power, which is always 1, and then 2 to the nth power. So this is another way of writing the problem that we just did. Now the Basal Sum looks like this. So, and it was actually figured out by Euler. Okay. And he lived in, I think it was a town called Basel at the time, and so did somebody else who tried to figure it out. Bernoulli, I think, maybe not. So it's also from n equals 1 to infinity, if I'm not mistaken, but it's n squared. Okay, yeah, n equals 1, because if it started at n equals 0, then we'd be dividing by 0, which isn't right. So this is the Basal Sum, and it actually equals, you're never going to guess, it equals pi squared over 6. What a crazy result. So we are going to talk about that next week. It's a lot more interesting. I just want to start off with the Zeno Sum because this is also, adding up an infinite number of things, positive things, getting a finite result. But that's going to be interesting. I think it's kind of cool how these relate to each other, though, because if you write these with caret notation, this right here is, there's a thing 2 to the nth power, and this one is n to the second power. Okay? And since, that exponentiation, the caret, isn't commutative, we get drastically different results, and it's very interesting just how they relate to each other, though. So stay tuned for that one. That one's coming next week. Stay tuned for Math Monday with the mathematics series, and I'll catch you guys in the next one.